Excellent. Great. Well, good morning. Thank you so much to the organizers of the conference for inviting me. This is my second time at a PyCon APAC. I spoke in Taiwan 2 years ago, and it was a smaller conference there. So I'm really excited that the organizers have been able to grow the size of the community and also keep the conference affordable to make it accessible to a large number of people so that we can all come to the conference. Sometimes conferences can become unaffordable, and some people can't afford to go. So it's really fantastic. I arrived here in Seoul yesterday from San Francisco. So if I misspeak, I will just blame it on the jet lag. Many of you may already know me and my work. I've been working in the Python community for many years now. I started the project that became Pandas in tell you a little bit more about that, but I started that project a little over 8 years ago, and I wrote the book Python for Data Analysis in 2012. Young-gun Kim, who invited me here to speak at the conference, was responsible for the Korean translation of the book. So if you own the Korean version of the book, you can thank him for the hard work on that. I've worked on many other projects. Since getting involved with Cloudera, I've been able to work on many projects in the Apache software ecosystem and the Hadoop ecosystem. And there have been and there have been a number of other Python projects that are in and around the same problem of building software that helps solve problems that involve data. I'll tell you more about those things. Well, I think one of the really exciting things about 2016 and in the future is the fact that I've been able to work many different places. I had a startup for a couple of years. I've worked for a technology company in the Bay Area. I've worked for a financial firm in New York. But I've been able to consistently work on the same kinds of software in each of those different places and to contribute that software to open source. And to have that kind of continuity in your work, working in different places is very rare and something that has been enabled by the general shift to open source software. And I find that to be very exciting and good for all of us in our careers moving forward. I'm working on the second edition of Python for Data Analysis. I have the problem of working on too many projects, but I hope to finish this one and to publish the book sometime in the first half of 2017 in English. So at some point, the Korean version and the other translations will trickle down. So be very excited to update the book to incorporate all of the great stuff that has happened in Pandas in the last 4 years, and also to incorporate some of the work that has happened in other projects in the Python data analysis ecosystem. So when I come to these conferences, I always find it very interesting to talk to people and understand what brought them to the conference. And it's different for every person. I know that the first time I went to a Python conference, I was working for a financial firm at the time, and I was speaking about using Python for quantitative finance work. And at that time, that was a fairly new and somewhat controversial idea. Not many companies were using Python to do that kind of work. And so I felt that talking about it openly in the community would help bring more developers working on those problems. But many people that come are simply looking to become a better Python programmer, whether that's learning about new tools, hearing about how other people have solved their problems, using how to pick the right set of open source projects and to build a working solution to a problem. Maybe you're looking for a new job, or maybe you're here with a sponsor and you're looking to hire other Python programmers. If you have an open source project, you might be looking to raise awareness about your project and get new contributors. And Python conferences are a great place to have conversations about the things that you're passionate about and to build new collaborations. So we're all here for different reasons, but what I've found about the Python community is that whether it's in Korea or the United States or in Europe, I found that we share a lot of the same values, and I can't name them all, but in general, I found that a lot of us program in Python and learn Python in the first place because it's fun, and if you're going to be a software engineer, you would like to enjoy your work every day. And I found that when I started programming in Python, that I enjoyed my work a lot more, and that's very nice. We also like to collaborate well with our colleagues, and Python is good for that, if only making your code more readable, so that if you write a piece of code and one of your colleagues works with that, then they have a good chance of being able to understand your code and work with it and develop a good collaboration. And we also have a healthy culture of taking our own specific solutions to problems and turning those into small or large reusable libraries of tools so that other people aren't having to solve those same problems over and over again. I've also found that Python programmers take a lot of pride in their software craftsmanship, and when you build something in Python, you deliver working software. I take a lot of pride. I know Python programmers take a lot of pride when other people look at their code and they find that the code is simple, or it's elegant, or it's intuitive, or maybe just readable. And that's more than you can say for a lot of code bases that you see out there in the wild. And part of that is that we don't just stop working on the code when it works. We can build the solutions quickly, but then invest the energy to make sure that the code is clean, that it's readable, it's well documented, and that other people can pick up that code and work with it. And that's part of the Python culture, which I think is really great. That's encapsulated in the Zen of Python. I think when people are starting to learn the language, everyone is told, hey, import this and read that, and you'll learn about what it means to be a Python programmer. And I think that kind of ethos is really important in kind of helping us look at problems in a similar way and work better together. So I ended up a software engineer and using Python basically by accident. I studied mathematics in college, and I took a first job. I was considering going to graduate school, potentially going into academia or some research field, but I decided, well, I'll take a break from school to work for a little while, and I ended up working at a financial firm called AQR, doing financial data analysis. And after about 6 months, I felt very strongly that it was taking too long for me to do my work, and I would have an idea, something that I wanted to try, and then I would spend a really long time, maybe all day or several days or a couple of weeks, just implementing that idea to a point where I could understand whether or not it was a good idea. And that process of iterating on the software, especially dealing with really messy data, I really kind of wanted to make 2 or 3 copies of myself to help clean the data and iterate on these problems faster. And unfortunately, it's not very easy to create copies of ourselves. So the best that we can do is to try to make ourselves more effective. And so I started, as an experiment, creating some libraries for my own purposes to make myself more productive, particularly for working with messy data sets So I found myself solving the same problem over and over again. So I made a function to help me with that. Made a few other functions, and pretty soon I had a library. And I showed it to my colleagues, and they said, hey, that's really useful. Can you install that on my computer so that I can be more productive too? And it was not long after that we had a fairly large project that was used by dozens of people and became a very important part of the company. And that was the code base that became the first version of pandas, which was a very small package when it was first released. And so I spend a lot of time thinking about tools. And so I'll use the metaphor of maybe you've used an axe and chopped down trees. And for people who chop down trees professionally, you can imagine a long time ago, before modern machinery, and you just had an axe and you would get really good at chopping down trees with an axe. And so maybe you're a new lumberjack and you're not very good at chopping down trees. And so there's somebody, there's the 10x lumberjack who can chop down 10 times as many trees as a new person who's just learning how to chop down trees. And then all of a sudden, somebody comes along with a chainsaw, and now everybody's a great deal more productive. And you can imagine how the person who was just amazingly good at chopping down trees with an axe felt when all of a sudden everyone can chop down 10 times as many trees. But I think this is great, and whenever you can create a tool that makes an individual more productive and more effective at their job, that's a really great thing. And I found that the Python community is good about identifying opportunities to create new tools to make individuals more productive. I think a part of this has to do with empathy, and I asked them to come up with I'm sure there's a Korean word for empathy, but the definition that I found for it, empathy is the idea that you can share and understand other people's feelings or emotion, or the ability to relate to other people's feelings. And in creating software for use by someone else in making tools, this is very important that you're able to put yourself in the shoes and relate to the experience of other people using the software. And I found that the Python community has a great deal of this. We spend a lot of time thinking about, is this hard to understand? Is this well documented? Maybe I'm very productive using this, but when I hand the software to someone else, how are they going to feel? Are they going to be frustrated? Are they, is it going to be hard for them to get work done with this code that you built? And so if you can connect with, whether you're a user and you're collaborating with people in your company, or you're building an open source library, I always think about the users first. So it's not, what is the software that Wes can use and Wes can be productive with? I think about, well, how is it possible, how might somebody use this function incorrectly, or they might struggle to understand something. There might be something that is confusing or difficult to use well. You might constantly be going back to the documentation and say, well, how does this work again? So the less that you can, the less that you can do that, and the more productive the users are, and I think that's great. And open source software has been amazing for tool development for a number of reasons. I think the biggest is that the fact that we're all, people from many different backgrounds and companies working on different problems are able to talk to each other and share their ideas for how to solve problems, how they've maybe already solved problems. And so this has accelerated the pace of innovation in many different areas. So you can imagine if all you had were the problems that were right in front of you and your colleagues, that the solutions that you build would be informed by those experiences rather than the perspectives of somebody from around the world who's working on a similar but different problem and might have a different idea about how to solve it. Open source can also be frustrating. And it can be frustrating both for the users of the software as well as the maintainers of the software. And so I'll speak a little bit about that, where some of the frustration can come from. And I think for contributors and also for the user community, a lot of it comes down to how to make open source software sustainable. So you as a user, if you pick up a new library that you discovered, on GitHub or you heard about on the internet, you might find that it does maybe 80% or 90% of the things that you need, but there's the 10 or 20% of things that it doesn't do. And so then it's like, well, do we find who the builder of the project, the developers, the maintainers of the project, and you can ask them to build those missing features. Maybe you implement some of those features yourself. But the trouble is, often, if it's solving a problem that you're not deeply familiar with, it will be much easier for the developer, the maintainer of the original developer of the project to do that work, rather than you learning all of the internal details of the project such that you can implement that missing functionality. And it's great when users become developers, and with the Pandas project, many of the core developers started out as users of the project, and they found that it was so useful for them that they started adding features, and pretty soon they're core developers. But it's hard because when you need something done, you're trying to get your job done, and there's this volunteer contributor somewhere else in the world, and there's really no financial relationship between you and that person. The software is free. You aren't paying them for it. I think you can agree on this is a good idea to do, but finding the time to do it may not be on a time scale that is, you need it to be done tomorrow, and it may not get done for 6 months, and that can be frustrating. There's a couple of questions around, how to make this process better and how to support the contributors and enable them to spend more of their time building free and open source software. So funding is a real hot topic, something that people are very interested in right now. And on the subject of bringing more money and more funding to open source software raises some questions about how do we bring more money and more financial support to the software development while also building a very positive and welcoming and healthy community, especially for the volunteers and the people who are not receiving any financial, any money for working on these projects. So on this first topic, and something that unfortunately from working on Pandas I'm quite familiar with is, and I don't know how this will be translated, but has been called by a number of people the grind. And this can mean many things to different people, but I know in the United States we'll say, oh, my job is a grind. I go into the office every day and I'm solving the same problems, and maybe it's not very stimulating, but it's important work and it has to get done. And so in the context of an open source project, I just recently, David Hannemeyer Hansen, the creator of Ruby on Rails, which is a much bigger and more successful project than Pandas, wrote about the grind as an endless stream of bug requests, demands, questions, and occasional inquisitions. And this is reasonable because you want to know about the bugs, and when you build a large project, the larger and more important and successful the project, the more work you create for yourself. Every time you add a feature, you can expect to have a steady stream of bugs, corner cases, problems with that feature. Because you don't have a clearly visible relationship with the users of that software, whenever you make a change, even a very simple change, you might break something that somebody was depending on. And so it's not uncommon for a very angry user of a project to appear on GitHub and you start accusing us of, I can't believe you changed this feature, and you guys are very inconsiderate, and part of it is it's hard to communicate over plain text and email and GitHub, and it's understandable to be really frustrated when your favorite open source project, you upgrade it and it breaks code that you wrote that depends on it. But it's a very real issue that as open source maintainers, we end up dealing with a lot of unpleasantness that is somewhat unintentional. People are upset or they're frustrated with the software, and that frustration gets directed at the small group of developers, maintainers of the project. So just to give you an idea of the scope of, is this my water? No. To give you an idea of the scope of pandas, it's an old project. I started working on it in April 2008, and the development really started taking off in 2011. And now, as of today, we've had over 600 people have contributed code to the project. But if you look at who are the really active, who are able to commit, push code to the project, and who's responsible for reviewing and merging pull requests on GitHub, it's actually a very small group of people. At any given time, it might be 3 or 4 people. Sometimes there might be 6 or 7 people that are active at a given time. But we are all volunteers, and none of us, even though the project has become so important to so many businesses, none of us are being paid necessarily to work on pandas as our full-time job or as part of our day job. But yet at the same time, especially over the course of 5 years, we've closed almost 7,000 issues and had over 5,000 pull requests. And we're talking about multiple pull requests per day, multiple issues per day. And that steady kind of churn of work can be very, very exhausting. And at the end of 2012, which is, I would describe as the inflection point, the change point where pandas started to get a lot of traction and become very, very popular, it was a very small group of people building the project. So I had been the only person working on it up until sometime, well, the years are not on there, but you can see where I started getting really active was in 2011, and I enlisted Adam Klein and Chang She, who were my colleagues from AQR, to work on the project with me. And we had started to get some major contributors. Jeff Reback, who became, who is now the second most active, has done, as much work on, or more work on the project than I have. But things were much simpler then. There weren't that many bug reports because there weren't that many users. But we worked really hard because we felt that Python needed to have this library to be successful for data analysis, and we were putting in the work to make that happen. But as a result now, we have hundreds of thousands of users and all of this work to keep the project going. So just to talk about funding and how to make the software sustainable, many of you probably know what this image is and heard about this a little over 2 years ago, but how many of you use the Openssl project? Okay, how many of you use a web browser or either on your computer or your mobile phone? So if you raised your hand, you all use Openssl, perhaps not directly, but indirectly, whenever you connect to your bank, whenever you send, an encrypted, whenever you send a text message, maybe it's even, well, maybe if it's been encrypted, it's fine, but if normal text messages, or really any data that's going over the internet that has been secured by, the TLS kind of, certificate-based, encryption protocol, in large part, I think 2/3 of web servers use Openssl, and that includes most banks and most, companies that deal with very sensitive data, your passwords, your answers to security questions, all of that stuff. And this came out, and everyone really freaked out because it was this really serious bug that had existed for several years. And a cybersecurity researcher described this And maybe this is hyperbole, but as the worst vulnerability found since the beginning of commercial traffic on the internet, which is a very, very strong statement. And it might be true, but the problem is we don't know, whether hackers in Russia or hackers elsewhere were able to exploit this vulnerability potentially for years and steal your sensitive information. It's very, very scary. And even scarier was the discovery that the Openssl Project only had one full-time supported contributor, core person who was being paid to work on the project. And another person from the team, wrote, kind of his impassioned plea that we need to have enough funding to have at least a half dozen experienced, security professionals who've implemented security libraries working on the project. And he is getting older, so he said, please, I'm getting old and weary, and I'd like to retire someday. And so I mean, I'm very young, but maybe 30 years from now, I will understand this a lot better. So there's a number of interesting research studies kind of looking at this problem, how to better fund open source. One that recently came out, I'll publish these slides so you can look up this study, which was funded by the Ford Foundation, about how dependent we've become on open source software, and yet everyone is dependent on it, but the willingness to invest money, even small amounts of money from a lot of people, everyone says, well, someone else will fix it. Like we don't have to help. But the problem is, everyone's problem becomes no one's problem. And so something that we say when talking about open source, a phrase that gets thrown around is the idea of the cathedral and the bazaar. And so the bazaar is like a marketplace, often kind of chaotic. And the cathedral model of software development is the traditional proprietary closed source software model where you buy software from IBM or Oracle or Microsoft or one of the the big technology companies, and for that financial transaction you're paying them to be responsible to fix the bugs. If you find something that is wrong, you can go to them and say, hey, we have this contract and I need this bug fixed right away. And it's a very kind of straightforward relationship, but it does rely on a certain amount of trust that the developers in the cathedral are looking out for your best interests. And so you could imagine a security flaw in a product from Microsoft that might go or from Oracle that might go undiscovered for a quite long time. Of course, the open source model brings anarchy to the process because we have, the code is open source, so anyone can look at it, which means that security vulnerabilities and bugs can be discovered. But the relationships between people and how, things get fixed, how features get implemented is a lot more distributed and chaotic, and relies a lot on relationships and knowing the right people and setting up ways to financially support work, whether it's hiring contractors to work on the projects or giving money directly to the projects themselves so that they can use the money to best grow the project. And so I bring this up because, well, when I started programming in Python, it was viewed as sort of risky. And I remember conversations like, well, the code is not compiled, so therefore it is not, it's not trustworthy, like it hasn't been verified by a compiler. And so then, well, we talk about unit testing and some of those things, but Python didn't have the reputation 10 years ago about being a mainstream, reliable, dependable language and ecosystem that you could be a safe choice for building your most sensitive, programs with. And that has changed, of course, and now in 2016, Python is a mainstream language, and a lot of that's been driven by success stories. So people who took the risk and made the gamble with Python. There's been, of course, a lot of development, and the open source software has become more mature. but on the basis of a lot of, people kind of taking the plunge, jumping off the cliff, using Python, and they were successful, has made, major investment banks and insurance companies, the governments around the world use Python to build their software. And that is an amazing success for our community and something we should be very proud of. But now, of course, given that the Python user base has grown so big, it is now big enough that it can support many businesses which build software that is sold either directly or indirectly to Python users. So that's very interesting and presents some challenges. So around Python becoming a mainstream popular language, I always think about an essay that venture capitalist Paul Graham wrote in 2004 called "The Python Paradox." I don't know if anyone has read this essay. It's a pretty famous essay, but the idea of the essay was that if you chose Python for a project and then you went to hire developers to work on that project, that you would in general get better developers for that project than if you had picked Java, say. And the idea and the reason for that was that if people had chosen to become experts in Python, it's because they're really passionate about programming and that they were learning the Python language because they thought it was a great language, not because they thought it would get them a job. Now, of course, 12 years later, things have changed, and you can go to a boot camp or a 3-month class, crash course in Python and get a job at the end of it. And so, things have, completely changed in the last 10 or 12 years. So one of the big challenges with this growing community and having talking about businesses based on Python, and also getting big companies to invest money into our open source projects, is how to have strong and clear governance around how do we make decisions in a way that is best for the community and best for the the companies who depend on these libraries and tools for their business. And whenever a company either dedicates internal engineers to work on a particular project, or they give money to the project, it often raises governance issues because people worry about, well, maybe this company is really they're buying that open source project and it's still open source, but they're making all of the decisions about what features get implemented and what bugs get fixed, and it stops being a community project and more of a part of this, commercial business. There's a number of ways to combat that concern. Yeah. I'm running low on time. So one of them is really being open and transparent about your process. So having discussions out in public so that people coming to the project understand how decisions are being made and how the developers are agreeing on what to do and what not to do. We can strive to reach consensus. So, it's great if you have 10 developers and you can all agree on the particular way to solve a problem. One of the Python programming language itself works based on consensus, but occasionally there's some disagreement, and in that case, they ask Guido van Rossum to make the executive decision to break the tie, so to speak. So I think that consensus, while very difficult and it requires a lot of work to get everyone to agree about something, and sometimes things can be very controversial, but it's something that really builds healthier communities and helps, if you have a company come in, bring a bunch of engineers to work on a project, that they also have to participate in this consensus-driven process to make decisions in the project. So several projects that and use, NumPy and Jupyter and pandas, we've all created formal governance documents in the last year to formalize our decision-making process. And this really helps companies who are giving money to the project to feel more comfortable about how that money will be directed and how we will make decisions. There's a couple of organizations that have been formed to assist with, to help open source projects grow, and also how to handle financial donations. So NumFocus was created primarily to support scientific computing, data science projects like pandas is a NumFocus project, NumPy is, IPython, Jupyter. And that provides a way for a company to give money to NumFocus that is earmarked, is intended for pandas development. And then we have, among the pandas developers, we can decide, there's a board of 5 of us, and we can decide how to use that money. The Apache Software Foundation has been around since the late 1990s and serves a similar function for the largely kind of Java-based ecosystem, but they also provide a formal governance model that all Apache projects are expected to use that has ideas around, all discussions are public, we make decisions on, based on consensus, and that's really great. An exciting initiative that has happened in the last year or so around Python packaging is something called Conda Forge to help build a community-curated repository of Python packages, especially those with very complicated or hard-to-build dependencies, C and C++ libraries. So if you've ever struggled to build a Python package, Conda Forge was designed as a community-centric way to collaborate and build a build script across platforms to build those packages. And so if you use Anaconda, you can add the Conda Forge channel, and even though there's only something on the order of 150 to 200 packages in Anaconda, there's over 700 packages in Conda Forge, and so it opens up a large set of Python packages to install. So I would be remiss to not talk a little bit about pandas and what's going on with the project, since I imagine many of you use the project. Right now, we're about to make the 19th major release of pandas. I released pandas 0.1 in 2010, and we're about to release pandas 0.19. And we've decided that maybe it's time finally for pandas 1.0. And we're intending this as to be a stable release that we focus on stability and bug fixes, and maintaining a stable branch that people can depend on. And over time, we've accumulated a lot of ideas about how we can improve pandas for the future, but it will be difficult to do without having a stable maintenance branch and beginning to make more invasive changes to pandas in like what we're calling pandas 2.0 branch. So pandas 2.0 will be intended to be backwards compatible, and largely reflects the fact that data science and statistical computing, machine learning use cases have become a lot more important for the community than the traditional scientific computing use cases from back in the early days of pandas. So the way that people are using the project has just changed a lot in general over the last 5 or 6 years. And in general, we want to make the project faster is always great. Use less memory. There's lots of ways that it can use too much memory. But in particular, there's a number of limitations in the project that relate to pandas' use of or dependence on NumPy that we would like to fix. And another thing there is we would like to make it easier to take pandas and connect it to other systems, so that pandas can become a useful component in the context of a much bigger system, where if you have a piece of data, you can hand it to pandas, transform it in some way, and then hand that off to another process, and that should be very, very seamless. I'm running out of time, but I've got 1 or 2 minutes. Another project I'm involved with that I'm very excited about in the Apache ecosystem is called Apache Arrow. The reason I'm very motivated about this is, in the course of working on pandas over the years, I've found that every time I want to connect pandas to a different database system or some kind of computing engine, that I'm having to build a connector between pandas and that system. And so the more components you have, the more connectors that you have to build. And a lot of the difficulty there is converting the data between the representation in one system and the representation that pandas needs. And so the idea with Arrow is to have a common memory representation for moving data from one system to another that is efficient and identical from system to system. So they won't necessarily have to use that format internally, but this will become like a, like a common currency kind of standard format to connect systems together at the data level. One thing we did recently to demo ideas of Apache Arrow is I sat down with Hadley Wickham from the R programming community, and we've been looking for a long time at ways for the R community to better collaborate with the Python community. And we decided to create a file format for storing data frames that we could use in both Python and R. And we used Apache Arrow for some of the internal details of implementing it. And based on, as a pun on the Arrow name, we called the file format Feather. And we shipped that. You can now install that in both Python and R, and is now a very fast way to move data back and forth between Python and R, so that data that you save from Python can be read in R and vice versa. So I'm very excited about doing more around making it easier to use multiple programming languages, multiple systems to work with data, kind of less friction to jump from one environment to another. So I'm out of time, but thank you very much for your attention. We are having a Pandas sprint here at the conference on Monday, so I will be around, and if you would like to pick off some issues on GitHub and make some pull requests to Pandas, that would be wonderful. Or if you just want to learn about the project, and I should have a good group of people there, so feel free to join us for that. And yeah, thank you.